Alright, today we're talking about solving equations with variables on both sides of the equation. Up until this point, we've been doing these multi-step equations to solve for a variable, but the variable has only been on one side of the equation, which makes that a little bit easier. So today, here are the steps we're going to follow to solve for a variable when it's on both sides of the equation. So first, you're going to simplify both sides of the equation if necessary, and we'll see examples of all of this today. So there might be some stuff to take care of on one side of the equation or both sides before we get to step 2, which is where we bring our variable terms together on one side. You're going to have some freedom to choose which side of the equation you want to bring your variables to, where we can combine them, but typically there is a better way to go about it, and I'll show you what I'm talking about once we get to an example. And lastly, once you've got that variable combined, or the variables combined on one side, you're going to solve for that variable just like we have up until this point. Alright, so make sure you get all these examples down today. They'll definitely help you out with this concept. Okay, so we're going to treat this equation when we're solving for a variable just like we treat any other equation when there's a variable present. If we're going to solve for it, whatever we do on one side, we have to do to the other side. First thing we're going to do is check both sides. Do I have to simplify anything on the left side? No, 7k is just there by itself. Do I have to simplify anything on the right side? 4k plus 15. I can't simplify anything on the right side because those two terms cannot be combined. Alright, so we can move to step 2, where we want to bring our variable terms together. Our variable terms are 7k and 4k, and I'm going to use this terminology, best friends or besties, BFFs, okay? Let's pretend that 7k and 4k are besties, and we want to bring them to one side of the equation together so that they can hang out. Alright, so we're going to choose and decide which way we want to go about this. I'm going to show you the easier way first. So for instance, if I want to bring 4k over to the left side, I have a positive 4k right there, so I can do the opposite of that, or take 4k minus 4k, which is 0. They just cancel out, okay? So that would be saying 0 plus 15 on the right side, but really I don't need to put the 0 there because 0 plus anything is just itself. So we have 15 left on that side, and I'm also taking 4k away on the other side. So 7k minus 4k is 3k. And there we go. We've combined our variables on one side of the equation, and now we can go to step 3 and solve for the variable. Alright, so since we're solving for k, and k is being multiplied by 3, I can divide by 3 on both sides. 3 divided by 3 is 1k, or just k, and 15 divided by 3 is 5, and we get k equals 5. Alright, so we can do that. We can go back and check to see if that works out. We can plug k back into the equation. I'm going to move some stuff around here real quick. And it does turn out that it will work out. So basically, if we put k back in, we get 7 times k on the left side. That's 35, or 7 times 5. And 4 times 5, which is 20, plus 15, which does equal 35. Alright, now some of you are probably wondering, well, what if I would have tried to bring 7k to the right side instead of 4k to the left side? You can still do that. I'm going to go through this fairly quick. But you get to choose, right? So let's say you decided to subtract 7k on both sides. Alright, well then you've got 7k minus 7k, which is 0, and 4k minus 7k is negative 3k plus 15. Alright, and then you have to, this adds more steps, so there can be, the decision you make could make your work a little bit easier or a little bit harder depending on which way you do it. You'll get very good at figuring out which way you want to bring these variables to make the equation easier. So now I want to get k all by itself. So I subtract 15 on both sides, and we get negative 15 equals negative 3k, and then we will get the same answer. We can divide by negative 3 on both sides, and a negative 15 divided by a negative 3 is going to be a positive 5, and we still get the same answer. All right. Typically, if the variable is already isolated on one side, like the 7k is, you want to bring its partner on the right side over, since it's already isolated on that one side. Excuse me. All right. These, A and B, require some simplification before we go about solving. So here we've got 2 times this quantity, so 2 times y plus 2 times 6 equals 3y, or 2y plus 12 equals 3y. And here again, we can choose. We've got 2 variables on either side that we can combine. We want to bring those besties together. Well, you ask yourself the question, would I rather bring 2y over or 3y over? And in this case, I would rather subtract 2y over. So 2y minus 2y, cancellation. You're left with just 12 on the left side, and 3 minus 2 is 1, so 1y or just y equals 12. And there we go, we have solved for that equation. So 12 equals y. You can plug that back in and see if it works out. Okay. There is one other option there for this one. Real quick, if you've got 2 times a quantity, you could have divided by 2 on both sides right away. And 2 divided by 2, you're left with y plus 6, which equals 3 over 2y, 3 halves y or 1.5y, whatever you want to think of. And then you take this. Some of you are going to avoid this one because it adds some fraction to it, but you'd want to subtract y on both sides. Or you can think of this as 2 over 2y, right? Because 2 over 2 is just 1. All right, and we've got 6 equals 1 half y. Well, half of what equals 6? Half of 12 equals 6. So we know that y has to be 12. So you can do it that way too. But like I said, some of you will avoid it just because there are some fractions. But if you have a distributive property going on, like 2 times y plus 6, you can divide by 2 right away if you want to on both sides, since 2 is a multiplicative step. All right. Anyway, hopefully that makes sense. You get the same answer either way. I would recommend doing the distributive property first for A. Same with B. So we're going to do the distributive property here. And actually, the problem with B is if we were going to start dividing by 3 right away, like on this one, I would have to divide this by 3, and I would have to divide this by 3, because they are not contained in one specific parenthesis. All right, so it's not one entire quantity. We have divide this on the right side. We can divide that whole thing by 3, but these are 2 separate things going on, and that's not even the way that I would start this one. So let's take a look at what we would do and make this easier, because that probably looked confusing as it can. All right. Still, you can go about it that way, but let's do it the distributive way, which is the way I recommend anyway. So we've got 3 times 1 and 3 times minus 2k. All right. So 3 times 1 is 3, minus 3 times 2 is 6, and we have a k with that. All right. Now I've got a couple different things going on. We have 2 constants on either side. We also have 2 variables going on either side. I like to try to get rid of negatives if I can. So for instance, I notice on the right side I have a minus 6k. And if I were to bring 2k over to the right side, like subtract 2k, I would be getting a negative term on the right side with my variables. On the other hand, if I add 6k, because remember, we're going to consider that a negative, so we're going to do the opposite of that, which is add. Well, opposite of subtraction is addition. Alright, so add 6k to both sides. Negative 6k plus 6k cancels. And I'm left with 2k plus 6k, which is 8k. Brought our besties together. Now we have 8k minus 5 equals 3. We want to get that variable isolated. So we've got 8k equals 8, and 8 times 1 is going to give us 8. We can figure that out by doing 8 divided by 8, and that's how we would go about that one. Alright, last two examples here. Very interesting what happens here. First of all, we want to simplify both sides on A first. We have a couple like terms that we can combine. Remember, this is going to be 1x if we don't see a very coefficient with that. It's 1 times x. So I'm going to do 1x plus negative 6x because they both have the same variable to the same degree. So 1x minus 6x or 1x plus negative 6x is negative 5x. And then we have plus 4 with no partner. Alrighty? And then on this side, the right side, I've got 6 plus negative 2. I can combine those. I'm going to write negative 5x. That doesn't have a partner. But 6 plus negative 2 is 4. And now we can notice that both sides of the equation are exactly the same. Negative 5x plus 4 equals negative 5x plus 4. If we start and try to bring our variables together, so for instance, if I add 5x to both sides, I get negative 5x plus 5x, that's 0, plus 4, and negative 5x plus 5x is also 0 plus 4, and we get 4 equals 4. This is true, alright? 4 does equal 4, and anytime that happens, this equation has infinite solutions. Any number that you put in for x will work. It'll make both sides of the equation equal. Go ahead and try it. You can put 0 in for x. Both sides of the equation will come out equal. You could put in negative 20. Both sides will come out equal. Okay? So that's kind of a special situation. And vice versa, we can have this happen, which is what's going to happen in B. Right? Everything looks good on the right side, but I do want to combine negative 8x plus 9x here. So negative 8 plus 9 is 1x, or just x. Same story. If I try to bring my variable terms together, x minus x is 0. X minus x also 0. We get 6 equals negative 17, and this is not true. Anytime this happens, this equation has no solution. You can put in anything that you want to for x, it will never come out that both sides are going to be equal. Right? So here's the sum, or the summation of what we've learned today with these equations with variables on both sides. 3 different outcomes. You can have a specific solution, you can have no solution, or you can have infinite solutions. And we will talk more about this tomorrow. But this is the basis of the variables on both sides of the equation when we're solving.